I got a little bit of feedback from you as a class. Not exactly sure what I meant, I guess, by the word enumerated. So what I'm trying to say is how many different things can I keep track of? So if you were to think of a string, let me come over here. I'll say, string name equals, I'll just give it a string literal. Shasta, right? We understand that there's indexes for each of these individual characters in that string, right? And we always start at index 0. So the S is at index 0, H is at 1, 2, 3, 4, 5. So if you look at it, the number of things that I have there are 6 things, and they're numbered 0 through 5. So that's kind of what's happening over here. So the goal is not to write this table out every time, but just kind of observe what's happening and then use that information for the future. So if I have only 2 bits available to me, right, that's an on-off switch from binary, how many different states can I represent? Well, if I've got a 0 and a 0, right, that's one state, and I can have a 0 and a 1. I could also have a 1 and a 0. And finally, I could have a 1 and a 1. And if you look at the numbers that these correspond to, this is the number 0, this is the number 1, and this is the number 2, and this is the number 3. So the largest number that I can represent is the number 3, but the largest number of things that I can keep track of that can be enumerated or create a relationship between these let's see, these are whole numbers. Between these whole numbers and things is 4. So with 2 bits, I can keep track of 4 things. Let's extend that to 3 things. So with 3 things, I have everything turned off. I have just the first one turned on. I can go with the only that one turned on. I can go with this one turned on. Now I'll do things with 2 things turned on. So I could have 0, 1, 1. I could have 1, 0, 1. I could also have 1, 1, 0. And also I could have them all turned on, 1, 1, and 1. So if I look at it now, you can see there's 1, 2, 3, 4, 5, 6, 7, 8 different things that I can keep track of. Right? So for a 2-bit number, there were 4 things that we could keep track of. For a 3-bit number, there's 8 different things we can keep track of. Do remember, though, the largest number here is 3, and this number, the largest number here, is the number 7. So if the question was asking, what's the largest integer that you can represent with a 3-bit number, the answer would be 7. What's the largest integer that you can keep track of with a 2-bit number? The answer would be 3. But if the question is how many different things you can keep track of, it's 1 more than that. Now there's a pattern here, and I hope you see this, right? In general, the number of things, and I'll just call it things, is equal to 2 raised to the number of bits that I have available, right? So I'm just raising it to a power, things probably with an S. And the largest number, so by the way, I could finish answering these. 2 to the 4th power would be 16. And 2 to the 5th power would be the number 32. However, the largest number that I can write down with 2, 3, 4, or 5 bits, that would be, I could write this largest int would be 2 to the number of bits available minus 1, so just 1 less than that. So if I can keep track of 32 things, my largest integer that I can represent with 5 bits is the number 31, etc.